Hi everyone, I hope that we are live now. Hi everyone, and I think you should be able to hear me. And I think so. You can just say yes in the chat box if you can hear me and see me clearly before we start. Okay, awesome, great. Today's was an easy question. Yeah, in true sense, it was an easy question. So, I would want to know how many of you were able to read, understand, and code the question. Could you code it out on your own and just say yes or no if you could? So we'll quickly read through the question. It says that we have been given an integer array, okay, and what we have to do is we have to sort this array. So we want to sort this array on the basis of number of 1 bits. Okay, so it's a very simple problem statement as long as you know how to represent a number in its binary notation. So if you have a very simple array, let's say you have 7, you have 2, and you have 4, okay, then what the problem basically says is that you have to sort this array in such a manner that the number in which the number of 1 bits is maximum, that should appear later, and the number in which number of 1 bits is minimum, that should appear before. So can you tell me what will be the binary representation of 7, 2 and 4? So 7, when you convert it in binary form, it will be 111, right? And this thing will be 10 and this thing will be 100, right? Now if you look at it, which number has the highest number of bits, highest number of set bits, highest number of 1 bits? It is 7. Because it is 7, so of course 7 should come at the end, right? Now when I look at 2 and 4, both of them have equal number of set bits. This also has one set bit. By set bit I mean 1 bit, okay. This also has one set bit. So in this case the question clearly says that in case there are 2 or more integers which have the same number of ones, which have the same number of set bits, in that case you have to sort them in ascending order. So here 2 and 4, both of them tie up because both of them have equal number of ones in their binary representation. So here I have to sort them in descending order, so ascending order. So it means that 2 should come before 4. So that is the output. So this is what is expected. Very simple expectation from the question, that you have to sort an array. So here, you know, coincidentally it has got sorted in ascending order, but let me assure you that it is not necessary. It is not necessary that your output would be in ascending order. For example, let's say you had a 3 also. What is the binary representation of 3? 11, right? Now in this case, when you look at 3, there are 2 set bits. When you look at 4, there is only 1 set bit. So which one should come first? Should 4 come first or should 3 come first? The answer is 4 should come first because there is only 1 set bit. So I should first have 4 and then have 3 and then have 7. Now it makes sense, right? Because it just has 1 set bit, it has 2 set bits, and it has 3 set bits. So basically the output could be anything. I mean, if any of you thought that arranging the array in ascending order will give us the right output, that's wrong. That's not correct. Is it clear to everyone? How many of you are perfectly okay with the understanding of question? So some of you are saying that you solved it using brute force approach. Some of you are saying had to make a comparator. Okay. So how would the brute force approach look like? In brute force approach, there is not much that you have to do. All of you can write some sorting algorithm. In this question, to be more specific, the length of the array is just 500. So even if you write a bubble sort algorithm or a selection sort algorithm, no problem. You will not get time limit exceeded. Okay, so even if you implement your order n square sorting algorithm, then all that you have to do is, whenever you are comparing two numbers, let's say array of I and array of j, then you don't have to compare their values. You don't have to compare their values. Rather, what you have to do is, you have to compare the number of set bits which are present here with the number of set bits which are present here. So I can imagine as if there is a method nums which takes an integer and returns that how many set bits are there in that integer. So imagine we are implementing such a method int nums which takes an integer I and tells you by returning that how many set bits are there in that integer. How many of you can implement this method? Can you just say yes if you can implement this method? It's super easy, right? Because we all know how to convert a number into its binary form. All that we have to do is we have to repeatedly keep on dividing number by 2 and keep on taking its modulus. For example, let's say if your number is 5, what do you do to convert it in binary? You take 5 mod 2, and what is 5 mod 2? It is 1, right? Now after taking mod, you divide 5 by 2. When you divide 5 by 2, what do you get? You get 2. Now you take 2 mod 2. 2 mod 2 is 0, right? And now you divide this 2 by 2. So now it becomes 1. Now you take 1 mod 2. 1 mod 2 is 1. And now you divide this 1 by 2. So now it becomes 0. So what basically has happened is that you repeatedly divide a number by 2, and while doing so you also take the modulus of number with 2. So that helps you to generate the binary notation. So this way we can very easily write a code that allows us to to figure out that how many set bits are there in that particular number, right? Okay, as simple as that. What will be the time complexity of this algorithm? So if at all I were to implement it, it probably would look something like this. I would say while I is positive, what am I supposed to do? I am supposed to find out the remainder when I divide I by 2, right? And I can have a count variable which is 0, and what I can do is I can do count plus equals to rem. So it means that if the remainder is 0, nothing will be added. If remainder is 1, that means the corresponding bit was 1 and it will be added. And after that I need to divide I by 2. This is all. This is literally the all code that you need to write. The time complexity of this is going to be log of this number, log of I, correct? Why log of I? Because if you divide something continuously by 2, of course after log of I iterations that thing will become 0, correct? Also if you look at it, what is the maximum value of a number? The maximum value of a number is 10 power 4, right? And log of 10 power 4, how much is that? Roughly 13 or 14. So I can say that in 13 or 14 iterations, in roughly 13 or 14 iterations, you will be able to check that how many set bits are there in any number. Now, no matter which sorting algorithm you are implementing, let's say your sorting algorithm is bubble sort. What is the time complexity of bubble sort? If the size of array is n, how much time does it take? N square, right? But here in this approach, in all the n square iterations of bubble sort, you will be doing this thing. I mean, you are not directly comparing array I with array j, right? You are first invoking these two methods to find out the number of set bits, and then you are doing that. And the complexity of this method, as we just figured out, is going to be roughly 13-14 steps. So the time complexity will be roughly around 13 into n square or something, and you can even ignore this 13 or 14 and you can say it is going to be order of n square. Now, all of us know better sorting algorithms. All of us know something like merge sort or heap sort. So we can implement something like that, and in that case, the complexity will be 13 into n log n. So again, you can say it is order of n log n only. All that is good. All that looks good. So this entire approach is brute force approach, right? And all of you, can all of you implement this brute force approach? Those of you who are present here, can you do that? Okay. Now, let me ask you one very simple question. Is there a scope of optimization here? Can we optimize something? Rachit has mentioned something. I was trying to think in this direction. Can we make use of the fact that perfect squares will only have single one in the bit? Okay, good. That's a very good thought. So how about others? Any scope for optimization? Okay, let's think of it in this manner. See, let's say there was a number array I whose binary representation was something like this. Let's say something like this. Okay. Tell me how many iterations of this loop will happen to figure out the number of set bits in it. The number of iterations will be equal to the number of bits which are present in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 iterations will happen. But tell me how many set bits are really there. Number of set bits are just 3. So if I am somehow able to come up with an algorithm whose time complexity is not equal to the number of bits, rather it is equal to number of set bits, then I'll definitely get some improvisation. I'll get some improvement. It may be a constant factor only, but still, for the sake of saying, it will be an improvement. It's a trick, and it's a very handy trick. It's a beautiful trick actually, and you have to pay some attention if you really want to understand it. So do you know it? How many of you know about this trick, by the way? Yeah, there is a big name for it, and one of you has mentioned it there. So how many of you know about this trick or about this? I also don't know the name of this algorithm. It is Brian Kerningham's algorithms. Apart from Faizan, anyone else who has heard of it or has known it? You can write about it, that how it works, if you know about it. Okay, so let's learn it. It's super easy. Tell me if there is a number n, and this number n, let's say, is a power of 2. If this number n is a power of 2, then how does its binary representation look like? Its binary representation looks something like this, right? There is only one set bit inside it, and it's natural, isn't it? I mean, so 2 power 0 is 1, and its binary representation is this, and then you have got 2, and then you have got 4, and then you have got 8. This is how it goes, correct? Now my question is, consider a number n which is a power of 2. Now if you have been asked to find the binary representation of n minus 1, then how will it look like? So just tell me the the binary representation of 2 minus 1. The binary representation of 2 minus 1 is just 1. What is the binary representation of 4 minus 1? The binary representation of 4 minus 1, 4 minus 1 is 3, and it is represented as 1, 1. What is this? This is 8. 8 minus 1 is 7, and 7 is represented as this. Similarly, what is next? The next power of 2 is 16. What is 16 minus 1? 16 minus 1 is 15, and 15 is represented in this fashion. Do you take note of one very interesting thing? The interesting thing is that the binary representation of n minus 1 just has ones. It has no zeros, it just has ones. Can you note it? Yes, no? Now, is it just a coincidence or can it be backed by some logic? The answer is it can be backed by a very strong logic. And what is that strong logic? Let's try to understand. See, if I give you a sequence which looks like which looks something like this, yeah, exactly what Rajit has written. You have 2 power 0 plus 2 power 1 plus 2 power 2 plus 2 power 3 and so on and on and on. And let's say the last place is 2 power n minus 1. Have you studied about this series? Have you ever encountered this series in your maths textbook of maybe class 10th or 11th ever? What kind of series is this? It's a geometric progression, right? And what is the formula for the sum of geometric progression? The formula is something like this: a multiplied by common ratio, which is r raised to the power n minus 1 divided by r minus 1. And what is r here? R is the common ratio. A is the first term. What is the first term? The first term is 2 power 0, which is 1. Okay. What is the common ratio here? It is 2. What is the number of terms? From 0 to n minus 1 there are n terms, minus 1. What is the common ratio? 2. So 2 minus 1 is 1. This thing is nothing but it is equal to 2 raised to the power of n minus 1. So what does it mean? It means that if you have any bit string which has all ones means this kind of sequence, correct? Because this one will represent 2 power 0, that one will represent 2 power 1, so on and on. Next one will represent 2 power 2, and the last nth one will represent 2 power n minus 1. So its sum is going to be 2 power n minus 1. So it means that if you consider any number which is a power of 2, then minus 1 of that will always have all ones inside it. Is it making sense? How many of you are able to understand the explanation to this thing, that why everything is 1 in n minus 1 if n is a power of 2? Yeah, now if you get this idea, then the job becomes pretty much easy. It is very, very simple actually, to be honest. So all that we have to do now is think of it in this manner. So let's say this is a number and I am calling this number as n. Can you guys quickly do something and tell me what will be the binary representation of n minus 1? Yeah, you can just write it in the chat box. Binary representation of n minus 1. Okay, so you're saying 1 0 0 0 1 and then you're saying 0 0 1 1 1. Okay, everyone else also is getting this thing. Now note one thing, this thing, it can always be written in this manner. You can say, take this part and after that there were 4 bits, so let all those 4 bits be 0. 1 2 3 4 plus this thing. You know, this number can always be written as a sum of this and that, isn't it? It can always be written as a sum of this and that. Now when you are talking about n minus 1 similarly can always be written as sum of this plus minus 1 of that, and minus 1 of that is going to be 0 triple 1. We already learned that, right? Everything is going to be 1 1 1. Now if you add this and that, what is it that you're going to get? You're going to get exactly that. So it means that if you take a number n and if you subtract 1 from it, what really is going to happen is whatever is the first one from backend, whatever is your first one, that one will become 0, and after that one, whatever zeros will be there, that will become 1. And this is very consistent with whatever I have explained you. Does it make sense? Do you follow this point? Yeah. Now tell me, at this point of time, if you take an AND of n and n minus 1, if you are taking AND of n and n minus 1, what will happen? What will happen? These things, when they are ANDed with these things, they will all become 0. Why? Because in the first 4 bits of the 2 items that you are seeing, where there is 1, you have 0 here, and where there are zeros, you have 1s here. So it is guaranteed that the first 4 things will become 0 and the remaining things will remain as they are. So basically the value of this expression is going to be this, correct? Now this is your number. This is your number. Now without using any calculation, can you tell me the value of n minus 1? Just based on whatever I have explained you, can you tell me n minus 1 from here? Yes, super easy, because using the same logic I can say if I do an n minus 1, all that will happen is this 1 will become 0, and after that all the zeros that are there will become 1. So this 0, and then how many zeros were there? 1 2 3 4 5. So I'll end up having 1 2 3 4 5 ones. Now if you take their AND again, what will happen? What will happen? All these things that you see, when ANDed with these things, will become 0, right? And only these things will remain as they are because they are exactly the same. So you have 1 triple 0, and after that you will have 1 2 3 4 5 6. You will have 6 zeros. So now this is your n. Now again, if you figure out your n minus 1, what will that be? 0 followed by all ones. I am not going to do that, you can understand. Now if you take AND of them again, what will happen? The value will be 0. So tell me how many steps were there? The number of steps that happened is exactly equal to the number of set bits which were present, because in the first step, the first set bit became 0. In the second step, the second set bit became 0, and in the last step, the last set bit became 0. So in this case, you are not going to have so many iterations. Rather, here the number of iterations will simply depend upon how many set bits were there in your input, or there in your number n. So this is one improvement that I can bring. So here, instead of writing this while loop, I can write the logic that I have just explained you over here. Does it make sense? How many of you understand this particular point? Yes or no? It's a very neat trick. It comes very handy, and it's a very popular interview question also, when people have to interview on bit manipulation skills. Can you please explain once why we are taking AND? Oh, we are taking AND because what we are trying to do is we are trying to vanish the set bits. So your original n was this, and your n minus 1 was this. So far everything is clear, right? Now if you focus on it, this part has not changed. This is same over here. Only this part has been complemented. Complement means 1 has become 0 and zeros have become 1. So naturally, if you take AND of this and this, that AND will lead to vanishing of this part. Why? Because you are taking AND of 1s with zeros and AND of zeros with 1s. But that part will remain as it is. So when we are taking AND, what is happening is that all the positions from first set bit onwards, they vanish, and when you repeat it again, all the positions from second set bit onwards vanish, and when you take it again, all the positions from third set bit onwards vanish. This is the idea. Do you now get it why we are taking AND? Yeah. So the number of iterations will be equal to how many set bits were there. Okay. So all that you have to do is, like here, what will change? Tell me. You will say that my I is going to be I and I minus 1, right? And then you can do a count plus plus. Now I'm not sure if I'm missing something in this loop. If I'm missing, then you can fix that out, but if you write this particular logic, your job would all be done, because all that you are doing here is whatever I explained you there. In each step you are taking AND of the number which you have with number minus 1, and then you are doing count plus plus. So of course by the time I would become 0, count would reflect how many iterations happened, and number of iterations that happened will be equal to number of set bits that were there. So yeah, you don't have to make any big change. Whatever logic you have, in that logic you have to integrate this particular bit level hack, bit level trick, and this will get the job done for you quite easily. Okay, great. So this is not going to have a drastic impact on the complexity, but yeah, I mean, because by some constant factor it will be there for sure. Okay, one more thing. Usually when such kind of questions are a part of your coding assignment and all, you cannot waste your time writing the code of sorting algorithm. So you can't, if you go ahead, sit and write the code of your sorting algorithm, that is going to take a lot of time. A better idea is to use comparator. Now how many of you are not aware of comparator? I mean, you don't know how comparators function. We have a YouTube video on your channel itself, and there I have explained in detail what is a comparator. So comparator is a mechanism through which you do not have to write the sorting algorithm. Rather, you just have to mention the logic. What kind of logic? That how to compare the two items. Like here, the two items are to be compared on the basis of number of set bits. So this is something which is worth watching. What I'll do is, I'll put the link to that comparator video on just below this video in the comment section when the class gets over, and you guys should definitely take a look at it. Take a look at it, it'll be quite helpful, and then the code that you will come up with will be super easy. I'll show you what kind of code I ended up writing with comparator. You can see how short the code is. That's it. This is all that the code is. I just invoked the sort method which is present inside the library STL, and then I passed the beginning and ending of array, and then I just had to write a comparator method. Now this comparator method, you can understand the logic of it, what it is doing. In this loop, it is counting the number of set bits in the first number, and in this loop it is counting the number of set bits in second number, and then it is comparing both of them, and based on that it is doing something. Now you might not be able to understand what is this, why it is returning this, why it is returning true or false. You might not be able to get that, but you will be able to get that when you watch that video which I am asking you to watch. Okay, so I'll attach the link to it, watch it, and then you will be able to write the code of it all on your own. So the homework for you guys today is to watch that video. Okay, trust me, that is going to be a big weapon in your artillery when you sit for interviews, when you sit for online coding assignments, and when you get questions like these which involve sorting. You cannot waste your time in writing merge sort or heap sort. Okay, even if you waste your time doing that, chances are highly likely that it might take you few iterations to correct it, to make it bug free. Okay, so the knowledge of comparator is super important in that. Cool. So I'll just share the link and do give it a watch. Today was an easy question. Tomorrow let's see what we get, and let's meet again tomorrow. Some of you were asking for the contest discussion. It couldn't be done yesterday because Bharat was supposed to do it. He had his birthday and was spending time out with family, but we'll continue it from this week onwards. Yeah. Okay then. Cool. So see you guys again. Bye and good night.